Hello, my name is Liang from the University of Illinois at Chicago. Thank you for virtually attending my presentation titled Neuromuscular Response to a Single Session of Whole Body Vibration in Children with Cerebral Palsy. Cerebral palsy is the most common motor disability in childhood. Children with CP often display neuromuscular impairments such as spasticity and loss of selective muscle control starting in early infancy. Due to their abnormal muscle activation patterns and muscle weakness, children with CP often develop abnormal gait patterns. Whole body vibration has shown its potential to reduce spasticity in children with CP after either month-long training or a single session of intervention. However, only one combination of frequency and amplitude was used in the previous studies. It is not clear whether whole body vibration with different frequencies and amplitudes can induce different outcomes on spasticity, or whether these benefits could translate to better motor function after a single session of intervention. The purpose of this study was to evaluate the neuromuscular response to a single session of whole body vibration with different amplitudes in children with CP. Our hypothesis was that compared to whole body vibration with a low amplitude, whole body vibration with a high amplitude would elicit better neuromuscular responses in spasticity and better motor function in gait. 10 children with CP with mean age of 10 years old and at GMFCS levels 1 to 3 took part in this pilot study. 2 sessions of side alternating whole body vibration were presented with the same frequency of 20 Hz but different amplitudes, low amplitude at 1 mm and high amplitude at 2 mm. Each session included 6 sets of 90 seconds of vibration and 90 seconds of rest. Participants' spasticity and motor function were tested at the baseline and immediately after each vibration session. They had at least 30 minutes of rest between the 2 vibration sessions. We used modified Ashworth scale to evaluate the spasticity of leg muscles, including knee flexors, knee extensors, and ankle plantar flexors with knee flexed and extended. We evaluated kinematics of gait patterns, such as spatial temporal parameters and knee and ankle range of motion during overground walking. We attached EMG on 4 muscles, including lateral gastrocnemius, tibialis anterior, vastus lateralis, and biceps femoralis to assess muscle activation during overground walking. For statistical analysis, the non-parametric Friedman test was conducted on the modified Ashworth scale mean ranks, and a series of one-way ANOVAs with repeated measures were conducted on the gait parameters. All significant levels were set at 0.05. Table 1 shows the mean and standard deviation ratings of the modified Ashworth scale. We observed reduced spasticity of the plantar flexors with the knee extended and flexed after both vibration sessions, but no difference was found between these 2 conditions. Figure 1 presents the results of ankle range of motion during overground walking before and after the 2 vibration sessions. An increase in ankle range of motion was observed after both vibration sessions, and the increase was significant after whole body vibration session with a high amplitude. After examining the EMG signals of leg muscle activations, we found a decrease of the integrated areas of the tibialis anterior during walking, as shown in figure 2 for one representative child. The EMG signals at baseline displayed constant activation with an identifiable phasic burst, which is a common pattern observed in children with CP. After both vibration sessions, the constant EMG activation decreased, which means a reduction of unwanted constant contraction of the muscle. Statistical analysis shows that the integrated area of tibialis anterior was smaller after both low amplitude and high amplitude of vibration sessions compared to the baseline. To sum up, our results suggest that a single session of whole body vibration with either a low or high amplitude can benefit children with CP by reducing the spasticity of the ankle plantar flexors and improving gait patterns. Moreover, the high amplitude whole body vibration increased the ankle range of motion during walking. Furthermore, low amplitude whole body vibration may induce similar neuromuscular response as high amplitude vibration in children with spastic cerebral palsy and can be used for those who are not able to tolerate stronger vibration. Thank you for listening to my presentation, and I can be reached at vliang@uic.edu if you have further questions.